So in this video, I'm going to talk about calculating, atoms and also moles. Okay. So I have this problem where it says calculate the amount of carbon in moles contained in 0.0265 grams of pencil lead. Well, we should know by now that pencil lead is made up of carbon, but if you don't know, that's okay. Okay. Is the process and the dimensional analysis is what I want you to see. And so I always start with what's given. So I'm given 0.0265 grams of carbon, okay? And I want to know how many moles were there. So essentially, draw my multiplication sign, my fraction bar, and then I go to this beautiful thing called periodic table. And so if I look at the periodic table, for every 12.011 grams of carbon, I have 1 mole. So that's the conversion. And so if I look at that, in this case, where do I want my grams to be, on the top or the bottom? Well, if I'm going to moles, okay, I need my grams to be on the bottom. So this would be 12.011 grams of carbon for every 1 mole of carbon, okay? And the reason why I wanted grams to be on the bottom, because notice I'm going to moles, and so if I multiply these two, in fact, grams will actually cancel, and the only unit that will left is mole. And so essentially, I'm dividing 0.0265 by 12.011 grams. And so when I do that, I should get about 2.21 times 10 to the negative 3 moles of carbon, okay? And so that would be my answer. Now, how do we calculate atoms? Okay, I have this question here that says, okay, well, how many copper atoms are there in a copper penny with a mass of 3.1 grams? Well, again, start with what's given. That's what these problems are. So I'm given that I have 3.10 grams of copper, which is Cu, okay? Now, how do we get to atoms? Well, the first thing that I usually do is that the first thing you usually should do is convert to moles first. That's a given. Okay, and so how do we convert to moles if we have 3.1 grams of copper? Well, I got to bring out the beautiful periodic table. And I see that copper, for every 63.546 grams, I get 1 mole. And so where do I want grams to be? On the bottom, because I need to get to moles first. And so if I look at this, this would be 63.546 grams of copper for every 1 mole of copper. Okay. Now, how do you get to atoms? Okay. The only thing left for us to do is use Avogadro's number, and we know Avogadro's number. It has units. Okay, for every 6.022 times 10 to the 23 something, I have 1 mole of that. Okay, now it doesn't have to be atoms. It could be molecules. Okay, it could be anything. But the idea is that if I have 1 mole of something, I have 6.022 times 10 to the 23rd if that's something. And so if I look at this, if I have 1 mole of copper, well, that's equivalent to actually 6.022 times 10 to the 23rd atoms. Atoms of copper, okay? It's just a conversion unit that we should know. So, in fact, if I take my calculator and take 3.1 and divide by 63.546, and then multiply by 6.022 times 10 to the 23rd power, let's see, I should get, so the answer should be equal to, when I plug this in my calculator, it should be 2.94 times 10 to the 22 atoms of copper. Okay, and this would in fact be my answer. So again, nothing hard. The process I want you to see is that I always start with what's given. Okay, notice that in both problems I started with what's given. And these I already solved these problems. Now, what if the question had asked, how many molecules, how many copper molecules are there in copper pen? You know what I'm saying? Like, how many molecules would be there? Okay, the question does not change. Okay, so in this case, the only thing that would change is that for every 1 mole of copper, for every 1 mole of copper atom, for every 1 mole of copper, I get 6.022 times 10 to the 23rd molecule. And so that's why I say Avogadro's number is not just atoms. It's, if I have 1 mole of anything, I have 6.022 times 10 to the 23rd, if that's something.